The Eternal Companion. A story of Andromeda for 99.9% of human history. Our ancestors saw a galaxy in the night sky every night. In 964, a Persian philosopher recorded it as a blurred spot. No one understood what it was until 1920. And today millions of people live without ever seeing it because of city lights. This is the story of our closest galactic neighbor, a silent witness to every human drama, every civilization's rise and fall, every whispered prayer under the stars. This is the story of Andromeda. The ancient light imagined standing on an African savanna 200,000 years ago. Above you, the Milky Way blazes like a river of diamonds, and there, nestled among the stars, a small patch of fuzzy light catches your eye. What is that pale smudge suspended in the constellation named for an ancient princess? It's Andromeda, and the light touching your retina began its journey 2.5 million years ago, before your species learned to craft sophisticated tools, before the first ice age your ancestors would endure. Every human who has ever lived under a dark sky has seen this light. The hunters who painted caves in Lascaux saw it. The builders of Stonehenge oriented their monuments beneath it. The pharaohs of Egypt, the emperors of China, the philosophers of Greece, all gazed upon this same celestial beacon, though none understood what it truly was. But here's what should make you pause. Andromeda has watched us far longer than we have watched it. While humans spent 200 millennia looking up at that fuzzy patch without understanding, Andromeda was already ancient beyond measure, its trillion stars burning through their cosmic dance for billions of years. Can anything make you feel simultaneously more insignificant and more connected to the universe? Yes, understanding that we are the universe's way of knowing itself. The Persian astronomers' eye the year is 964 CE. In the city of Isfahan, under skies so dark that the Milky Way cast shadows, a Persian astronomer named Abd al-Rahman al-Sufi bends over his manuscripts. Al-Sufi is compiling the most comprehensive star catalogue of his time, building upon Ptolemy's ancient work but adding his own meticulous observations. On a moonless night, he turns his attention to the constellation Andromeda. There, where no single star should be, he sees what he describes as a small cloud. How small? To his naked eye, it appears about the width of a finger held at arm's length. He writes it down carefully in his book of fixed stars, noting its position, its appearance, its unchanging nature among the wandering planets and the fixed stars. Al-Sufi doesn't know it, but he has just become the first human to formally record what we now call the Andromeda Galaxy. He calls it the Little Cloud, and for centuries that's all it remains, a curiosity, a fuzzy aberration in the perfect sphere of the heavens, neither star nor planet nor comet. But what was Al-Sufi actually seeing? He was observing the combined light of 1 trillion stars, so distant that they blur together into a soft glow. He was looking at a structure so vast that light takes 220 million years to complete a single rotation around its core. He was gazing upon a galaxy that spans 220,000 light-years from edge to edge, more than twice the diameter of our own Milky Way. And he saw it all compressed into a small, pale smudge. For nearly a millennium after Al-Sufi's observation, Andromeda remained a mystery wrapped in that fuzzy patch of light. Astronomers catalogued it, gave it various designations, argued about its nature. Was it some sort of glowing gas? A nearby nebula within our own stellar system? No one could say for certain. The great debate fast-forward to the early 20th century. The year is 1920, and the astronomical world is embroiled in what history would call the Great Debate. The question at stake is profound. What is the true size of the universe? On one side stands Harlow Shapley, arguing that our Milky Way is the entirety of the universe, and that those fuzzy spiral nebulae, including Andromeda, are merely clouds of gas within it. On the other side stands Heber Curtis, proposing the revolutionary idea that these nebulae are actually island universes, separate galaxies like our own, scattered throughout an unimaginably vast cosmos. Who would prove to be right? Neither entirely, but Curtis was closer to the truth. The answer would come not from philosophical debate but from careful observation and a remarkable woman who would change our understanding of the universe forever. Enter Henrietta Swan Leavitt. Working at Harvard College Observatory, Leavitt discovered something extraordinary. Certain stars called Cepheid variables pulse with a brightness that corresponds directly to their true luminosity. Why does this matter? Because if you know how bright something truly is and you can measure how bright it appears, you can calculate its distance. Leavitt had given astronomers a cosmic measuring stick. Edwin Hubble, working with the newly constructed 100-inch Hooker telescope at Mount Wilson Observatory, turned his attention to that ancient fuzzy patch in Andromeda. Night after night in 1923 and 1924 he photographed it, searching for those Cepheid variables. And there they were, pulsing stars within the Andromeda Nebula, their light signatures clear and measurable. When Hubble calculated the distance using Leavitt's method, the result was staggering. Andromeda wasn't inside the Milky Way at all. It was nearly 1 million light-years away. What did this mean? It meant that the universe was far, far larger than anyone had imagined. It meant that our galaxy was just one of countless others, scattered like islands across an ocean of space. The fuzzy patch that Al-Sufi had noted as a small cloud was revealed to be an entire galaxy, a colossal structure containing hundreds of billions of stars, its own planets, its own nebulae, its own black holes and stellar nurseries. Andromeda wasn't a curiosity within our cosmic neighborhood, it was a neighboring cosmos itself. Can you imagine the feeling of that revelation? Yes, it must have been like learning that what you thought was your entire world was actually just one room in an infinite mansion. A portrait of our neighbor. Now that we know what Andromeda is, let's truly understand what we're looking at when we gaze upon that patch of light. Andromeda, officially designated Messier 31 or M31, is a barred spiral galaxy. What does that mean? Picture a cosmic hurricane, a vast disk of stars rotating around a central bar-shaped structure, with spiral arms sweeping outward like the curve of water swirling down a drain, except this drain is 220,000 light-years across and contains 1 trillion stars. How massive is it? Andromeda's mass is estimated at roughly 1.5 trillion times the mass of our Sun. It's the largest galaxy in our local group, a collection of more than 50 galaxies bound together by gravity. Our Milky Way, with its 200 to 400 billion stars, is Andromeda's smaller sibling, orbiting a common center of mass along with dozens of dwarf galaxies. At Andromeda's heart lies a supermassive black hole, weighing in at approximately 100 to 200 million solar masses. Is it active? No, it's relatively quiet now, but evidence suggests it consumed a smaller galaxy about 2 billion years ago, and the stellar remains of that cosmic meal still swirl in Andromeda's bulging core. The galaxy's spiral arms are traced by bright blue regions, nurseries where new stars are being born even now, even as we speak. What are those darker lanes between the arms? They're vast rivers of dust and gas, the raw material from which future generations of stars will form. The outer regions glow with the cooler red and yellow light of ancient stars, cosmic elders that have been burning for billions of years. Andromeda isn't alone. It has at least 14 known dwarf satellite galaxies orbiting around it, just as the Magellanic Clouds orbit our Milky Way. These smaller galaxies are being slowly consumed by their larger companion, their stars gradually absorbed into Andromeda's vast spiral structure. It's a reminder that galaxies are not static objects but dynamic, living systems that grow and evolve over cosmic time. But here's where the story becomes personal, even urgent. Andromeda is moving. And it's moving toward us. The cosmic collision right now, as you read these words, Andromeda is approaching us at approximately 110 kilometers per second. About 250,000 miles per hour. Should we be concerned? Not for the next 4 billion years or so, because that's when the collision will begin. Yes, you read that correctly. Andromeda and the Milky Way are on a collision course. What will happen when these two galactic titans meet? The merger will be a slow-motion cosmic ballet lasting billions of years. The galaxies will first pass through each other, their stars so widely spaced that actual collisions between individual stars will be rare. But the gravitational forces will be immense, warping and distorting both galaxies, pulling out long streamers of stars, triggering massive bursts of new star formation as gas clouds collide and compress. They'll swing past each other, then fall back together, merging and re-merging in a gravitational embrace that will eventually form a single giant elliptical galaxy. Astronomers have already given this future galaxy a name, Milkomeda or sometimes Milkdromeda. What will this mean for Earth? If our planet and our sun still exist by then, and that's a big if, our night sky will be transformed beyond recognition. At the beginning of the merger, Andromeda will dominate the night sky, appearing not as a small fuzzy patch but as a vast, glowing spiral spanning from horizon to horizon. The gravitational disruptions might fling our solar system into a different region of the merged galaxy, or even eject us into intergalactic space. But don't worry, the odds are overwhelming that nothing will actually hit us. This cosmic collision is not an ending but a transformation. a reminder that the universe is not static but constantly evolving, galaxies merging and growing, stars being born and dying, new worlds forming from the ashes of old ones. Finding Andromeda. Your connection to infinity. Now comes the most important part of this story. How you can see Andromeda yourself, how you can establish your own personal connection to this ancient light. What do you need to see Andromeda? Less than you might think. The most essential requirement is not a telescope but darkness. True darkness, the kind that has become increasingly rare in our modern world, is both the challenge and the gift of this journey. Let's start with the basics. When can you see Andromeda? In the northern hemisphere, Andromeda is best visible from August through March, with peak visibility in autumn, September, October, and November. During these months, the galaxy rises high in the evening sky, away from the horizon's light pollution and atmospheric distortion. What about your location? This is crucial. You need to escape the light pollution of cities. That familiar orange glow that blankets urban areas, washing out all but the brightest stars, is the enemy of deep sky observation. You need to travel to a dark sky site, a rural area, a national park, a mountaintop far from city lights. How far? Use a light pollution map online to find areas classified as Bortle Class 4 or darker. The difference between a city sky and a truly dark sky is not incremental, it's revolutionary. On a moonless night under dark skies, the Milky Way should be clearly visible as a luminous band across the sky. If you can't see the Milky Way, you're unlikely to see Andromeda well. Can you see thousands of stars instead of dozens? Then you're ready. Now, how do you find it? Start with the constellation Cassiopeia, that distinctive W or M shape high in the northern sky. Cassiopeia is your signpost, always visible from mid-northern latitudes, circling the celestial pole. From the rightmost star of the W, draw an imaginary line downward toward the horizon. This line points toward the square of Pegasus, a large rectangle of 4 moderately bright stars. Find the uppermost left star of this square. That's Alpheratz, which is actually part of the constellation Andromeda. From Alpheratz, look for a curved line of stars extending to the left. This is the constellation Andromeda, the chained princess of Greek mythology. Follow this chain of stars. The first bright star is Merak, the second is Almach. Now comes the moment of discovery. From Merak, look upward for 2 fainter stars arranged roughly perpendicular to the main chain. These are your final guideposts. Between these 2 stars and slightly above them, you should see a small oval-shaped smudge of light. Is it a cloud? No, it's Andromeda. What should you expect to see with the naked eye? Under excellent conditions, Andromeda appears as an elongated, fuzzy oval, much larger than you might expect. It actually spans about 6 times the width of the full moon in the sky, though only the bright central core is typically visible without optical aid. It's not dramatic or colorful like photographs suggest. It's subtle, gentle, like a whisper in the darkness. Don't look directly at it. This is key. Use averted vision. Look slightly to the side of where you think Andromeda is, and it will appear brighter and more distinct. Why does this work? Because the periphery of your retina contains more rod cells, which are more sensitive to faint light. Your peripheral vision is actually better at seeing dim objects than your central vision. What if you have binoculars? Now the experience transforms. Even modest 7 by 50 or 10 by 50 binoculars will reveal Andromeda's elongated structure, the bright core, and hints of the spiral disk extending outward. You might glimpse the dark dust lane that cuts across the galaxy. With binoculars, you can also spot M32, a small companion elliptical galaxy appearing as a bright spot near Andromeda's core, and M110, another dwarf elliptical companion. With a small telescope, a 4-inch or 6-inch reflector, the view expands dramatically. You can trace the full extent of the spiral arms, see the dust lanes more clearly, observe the satellite galaxies in greater detail. But here's a secret: sometimes less is more. A wide-field view in binoculars can be more impressive than a telescopic close-up, because it shows you the galaxy's full extent in context with the surrounding stars. What about photographing Andromeda? The digital revolution has made astrophotography accessible to anyone with a camera and tripod. Even a 30-second exposure with a DSLR or mirrorless camera at ISO 3200 will capture Andromeda in all its spiral glory, revealing colors and details invisible to the eye. What you'll see in photos that you can't see visually: the pink glow of hydrogen emission nebulae in the spiral arms, the true extent of the galaxy spanning more than 3 degrees across the sky, the golden core and the blue young star clusters scattered throughout the arms. The experience of connection, but here's what no photograph can capture. The experience of seeing Andromeda with your own eyes, of knowing that the photons landing on your retina traveled for 2.5 million years to reach you, of understanding that you are seeing the galaxy not as it is now but as it was when your distant ancestors were just learning to walk upright on the African savanna. When you look at Andromeda, you are looking through time. You are seeing 1 trillion stars as they existed before the Pleistocene epoch, before the ice ages, before modern humans had fully evolved. Some of those stars you're seeing have already died. They exploded as supernovae hundreds of thousands of years ago, but their light hasn't reached us yet. Other stars have been born in the time it took for that ancient light to cross the void, and we won't see their light for another 2 million years. This is what makes the experience of observing Andromeda profound. It's not just about seeing a pretty celestial object. It's about connecting across unimaginable gulfs of space and time, about understanding your place in a universe so vast that our entire human history is less than an eye blink in cosmic terms, yet so intimately connected that we are literally made of the same atoms forged in the hearts of stars like those burning in Andromeda's spiral arms. The vanishing sky, but there's urgency to this story, a melancholy note that brings us back to the opening words. Millions of people live without ever seeing it because of city lights. Light pollution is erasing the night sky from human experience. Studies show that more than 80% of the world's population now lives under light-polluted skies, and in the United States and Europe, that figure rises to 99%. The Milky Way, which should be visible on every clear, moonless night, is now invisible to 1/3 of humanity, including 60% of Europeans and nearly 80% of North Americans. And if people can't see the Milky Way, they certainly can't see Andromeda. An entire generation is growing up never experiencing true darkness, never seeing more than a handful of the brightest stars, never feeling that sense of cosmic connection that comes from standing beneath a sky ablaze with stars. What are we losing? We're losing more than just starlight. We're losing our connection to the cosmos, our sense of perspective, our understanding that we are part of something larger than ourselves. For 200,000 years, humans looked up at the night sky and wondered. That wonder drove us to create art, develop science, build civilizations. The stars were our companions, our calendar, our navigation system, our inspiration. They reminded us that there was more to existence than our immediate concerns. The loss of the night sky is also an environmental crisis. Artificial light at night disrupts ecosystems, affects wildlife behavior, wastes energy, and may even impact human health. Sea turtle hatchlings, which navigate by starlight, become disoriented by artificial lights and never reach the ocean. Migrating birds crash into illuminated buildings. Insects, which form the base of many food chains, are drawn to lights where they either die directly or become easy prey. But the loss is also cultural and spiritual. Every culture in human history has star myths, creation stories written in constellations, traditions of reading the sky. When we lose sight of the stars, we lose these connections to our past, to our ancestors, to the stories that bind us together across time and culture. Can we reclaim the night sky? Yes, but it requires action, using shielded outdoor lighting, supporting dark sky initiatives, creating protected dark sky parks, and simply turning off lights we don't need. The good news is that light pollution is reversible. Turn off the lights and the stars return immediately. The story continues. Our story began with a simple observation. For most of human history, our ancestors saw Andromeda every night. It was there in the sky with them, a silent companion, constant and unchanging. They didn't know what it was, but they saw it, and in seeing it they were connected to something vast and mysterious. Abd al-Rahman al-Sufi gave it a name and a place in the catalogue of the heavens. For nearly a millennium, it remained a curiosity, a fuzzy patch that didn't quite fit the perfect clockwork of the celestial sphere. Edwin Hubble, building on Henrietta Leavitt's work, revealed its true nature. Not a cloud or nebula within our galaxy, but an entire galaxy itself, a trillion-star island universe so distant that its light takes 2.5 million years to reach us. With that revelation, the universe suddenly became unimaginably larger, and our place in it proportionally smaller, yet somehow more meaningful. Now we know that Andromeda is approaching us, that in 4 billion years our two galaxies will merge in a slow-motion collision that will reshape the cosmos. We know that it contains planets and nebulae, black holes and stellar nurseries, the same cosmic ingredients that make up our own galaxy. We know that the light we see today left Andromeda when our ancestors were just beginning their long journey toward becoming fully human. And we know how to find it, how to see it with our own eyes, how to establish that ancient connection that our ancestors maintained for 200,000 years. The story of Andromeda is ultimately a story about perspective. It reminds us that we are both infinitesimally small, brief sparks in an ancient universe and cosmically significant, because we are the part of the universe that can wonder about itself, that can trace its own history, that can look at a fuzzy patch of light and understand that we're seeing a trillion suns from 2.5 million years in the past. When you go out tonight or tomorrow night or next week when the moon sets early and the sky is clear, and you find that fuzzy oval in the constellation Andromeda, remember this. You are seeing the same light that Al-Sufi saw in 964, that ancient humans saw 50,000 years ago, that Neanderthals saw before them. You are connected across time to every human who has ever looked up and wondered. You are participating in a story that began before our species existed and will continue long after we're gone. In that moment, standing in the darkness, looking up at a smudge of light that is actually a trillion suns, you are not separate from the universe. You are the universe looking at itself, understanding itself, appreciating its own vast and intricate beauty. And that, perhaps, is the most profound discovery of all. Not that there are other galaxies, not that the universe is unimaginably vast, but that we are here to witness it, to understand it, to be moved by it. We are the cosmos made conscious, stardust contemplating stardust, temporary patterns of matter and energy that can nevertheless look up at the night sky and see not just light but meaning. So go outside. Find a dark place. Let your eyes adjust. Trace that line from Cassiopeia to the square of Pegasus. Follow the chain of stars that form Andromeda's constellation, and find that fuzzy patch. Look at it with your own eyes. Think about the distance that light has traveled. Think about the trillion stars you're seeing compressed into that small glow. Think about the ancient light touching your retina, photons that began their journey before our species evolved. And remember, you are not separate from this. You are part of this cosmic story. Your body contains iron forged in dying stars, calcium from ancient supernovae, carbon from stellar cores. You are made of the same material as Andromeda, governed by the same physical laws, existing in the same unfolding universe. The light from Andromeda connects us not just to distant space but to deep time, not just to other worlds but to our own origins. When you see it, you are participating in something ancient and ongoing, something that will continue long after we're gone but which, in this moment, includes you. That fuzzy patch in the night sky is not just a galaxy. It's a mirror reflecting our place in the cosmos. It's a teacher revealing the vastness of space and time. It's a companion traveling with us through the darkness. It's a promise that there is more, always more, to discover, to understand, to wonder about. This is the gift that Andromeda offers: perspective, wonder, and connection. All you have to do is look up.